So now it's time to do mixing up our urethanes. What I'm going to do is I'm going to stir up the urethanes, make sure the two parts of the urethane to make sure they're well mixed. Just make sure that you don't end up with settled particles and whatnot on the bottom, which can be a problem. The only downside to the stirring is it actually introduces a lot of bubbles into the urethane, but we'll vacuum that out and degas the urethanes before we put them into our molds, and then we'll do it again. It's a lot of vacuuming. So, good vacuum system works well on this. We have from JB Pumps, which is Just Better Pumps, their Platinum vacuum pump, and then we also have a Best Value Vax vacuum system. The two parts of this urethane, there's one really thick clear one in the yellow can, and then this kind of darker brown really flowy one and the blue. The blue is much easier to deal with than the yellow. I have two syringes, which 1.5 millimeter needles essentially into them. So what I want to do is I want to draw about 6 cc's into this one, into each. So these urethanes are made to be mixed 1-to-1 by volume, not by weight. I made that mistake once, don't ever do that. Their densities are off by enough to make that really a bad time for you. As you may be able to see here, drawing this liquid in is a very slow, kind of shitty procedure. I think we could come up with a better one, but again, time constraints. It does work as kind of a vacuum degassing system. You're drawing a vacuum with the plunger and it's pulling up the fluid, which is nice, but at the same time you end up with a lot of bubbles in the syringe. Things aren't super time critical right now, because things aren't mixed, the two parts aren't mixed. The only thing that is you kind of want to hurry, because you don't really want these containers open a long time. Air really thickens up the two parts of the urethanes. So right now I have maybe 7 milliliters of part A. I'm going to let the bubble rise to the top. I can actually do that while I'm doing B part. So as you can see, B part flows much better. So there is right at 7. What I want to do though is flip these upside down and get the bubbles out. By doing that, I can be a little more accurate in my measurements. I am right at 7 on the back end of the second half of the plunger. I know that's kind of an obscure number, but it is something I can make repeatable on this. 7. Okay, so now I have equal parts A and B. I like to do A first. This is kind of a preferential thing. And this may not even be enough. What we did last time was we actually mixed up a bit more. However, it always seems like I make way too much. So this time I'm going to say 14 cc's of mixed fluid is adequate. So stirring it into the dish, and then I'm going to take the thinner of the materials, the B part. I'm going to use it because it's easier to get most of it off of the mixing stick. It's a pretty stupid reason, but it works. And I'm going to mix this stuff pretty thoroughly. Again, like bubbles, it's nice to not get them in, but at the same time we're about to degas this system, so that'll be okay. You can see kind of the coloring in there. You get like a light tan and a clear. You want to make sure that's nice and even. You can get it pretty close. The degassing is going to stir it a little bit because the bubbles rising to the top. It's kind of like an interesting percolation system. I'll say that is mixed well enough. I'll put this into my vacuum chamber and then I'll show you what that looks like. So now we're going to take this. We have limited time now, so I may get a little curt with the camera. I'm going to close this valve, make sure this one's open, turn the vacuum pump on, and move some of this stuff out of your way so you can see. You want to watch your vacuum gauge, which is here. You can't see the face of it, I know, but believe me when I say it is at negative 15 inches of mercury and climbing still. 17, getting close to 20. I don't know if you can see the bubbles down in there. You should be able to see the petri dish basically. What we're looking for is that to take all those tiny little bubbles that are in there and make them all expand to huge and pop. This makes, whenever we go to put the urethane in our molds, it makes it much less of a hassle and a mess. And while that's going, I'll clean up my 2 parts of the urethane. I want to make sure get that stuff taken care of and buttoned up so that it doesn't start to harden with us, porous, whatever, the inside of this, the yellow and blue tubs. We're looking at negative 27 or so inches of mercury. And you can see the bubbles are kind of forming a bit quicker. Mildly uneventful, I'm sure. Camera's going to work really well as a timer for me. We got 30 minutes for this stuff to set up and become unworkable. So we kind of want to move as fast as we can. We're sitting at maybe 5 minutes, 20 seconds since the mixing. The thing you need to be careful of is what we're going to do is we're going to draw a vacuum, pull the bubbles out. Then I'm going to deep vacuum this vacuum chamber. And when I do that, I need to be careful not to crack the valve open too fast because it'll blow the molds everywhere. And that is not fun to chase down. You can see the bubbles are starting to kind of slow down now. And when we release the vacuum, you'll see all those bubbles that are left will actually shrink down to super tiny. I don't have to get all of them out, I just want to get most of them out. In the interest of time, we end up cutting it a little short. So I'm going to say that amount of bubbles is okay. And you can see the bubbles shrink whenever I open the valve. And it's still blowing my molds around, as you can see. You try to be as careful with this stuff as you can. Take the pump off. So now I'll have to rearrange my molds, which is okay. I just don't want to blow a bunch of dirt and stuff into them. That's one of the big things I want to avoid. Okay, so once the vacuum is down enough, I can pop the top off of this dude. Here, let's get my molds ready. So this process is interesting enough. We start with the fingertip, and then we move to the proximal end of the circuit board. So I'm going to pour some of my urethane into the tip. Just to fill it up. Now how this is going to work is basically I've got this mold filled up as much as it can, and when I push the plug down into it, it's going to displace some of that material, and that's going to help it fill the entire void. We will run up with a couple of little bubbles, but that's why we're doing this 2-part molding process. That allows us to make the sensors correctly, and then any air bubble that's in the system afterward is, while it's not a great thing, it's not going to cause us like any type of catastrophic failures or anything. It's not going to make our sensors not work. So I'm going to fill those up. These are the 2 medial molds here. And now what I'm going to do is I'm going to actually vacuum these again. And that way we know we've got molds full of urethane. Okay, close valves, vacuum on. Now you should be able to see more. Let's see if I can get better lighting for this.
that's not good. Sorry for the glare on that one part. Can't really see well. These two pieces up here, which are blurry as hell right now to you, I'm sure, are proximal molds. What I'm going to do is I'm going to slip the parts that have already been proximal molded but had big bubbles in them. I'm going to put them into that, and then I'm going to pour that excess urethane I have into those to fill up as much as I can. I want to run this for maybe 3 minutes or so, just to get the majority of bubbles out. I'm not going to get everything out, I understand this, but whenever you vacuum and you get the big bubbles out, it makes a huge difference. Makes it look a whole lot better on the finished product. I'll actually pause here and then we'll catch you up whenever I start to